This is a medium-level Newton's second law problem. The question involves two blocks connected by a string, and this tricks many students. Take a moment to try the question on your own first before we go through it together. Okay, let's break it down. The question asks for the acceleration of block y and the tension in the string. Since acceleration is involved, Newton's second law is our starting point. Let's slow down and categorize the forces into individual forces and the resultant force. This will keep you organized. Alright, look at the diagram and identify the individual forces acting on block y. The first one is a 12 Newton pulling force to the right. The second is the tension to the left. The surface is smooth. This means there's no friction. In this way, the resultant force on block y equals to 12 Newton minus t, and this equals to the mass of block y times its acceleration by Newton's second law. Now notice this equation gives us two unknowns, tension and acceleration. That means one equation is not enough. We need another one. So how do we do it? Here's a trick. Since block x and block y are connected by a string, they move together with the same acceleration. So we can treat them as one combined system. For the combined system, there is a 12 Newton pulling force to the right. Tension is no longer considered here because it is an internal force within the system. We only need to consider external forces. Frictional force is an external force, but in this case, it's 0. So the resultant force on the system is just 12 Newton. And by Newton's second law, this equals to the mass of the whole thing, which is the mass of x plus the mass of y times acceleration. That gives us the acceleration, which we can then plug back into block y's equation to find the tension. Now let's make a plan for this question. First, apply Newton's second law to the whole thing of block x and y, and we will get our first equation. Next, apply Newton's second law again to block y only, and we'll get another equation. Solve for the two equations, we'll get the final answer. Alright, let's move on to the solution part. For the combined system, apply Newton's second law equation, F equals to ma. It's always a good habit to write down the equation before going further into details. Then let's manipulate the equation. The resultant force on the combined system equals to the mass of both x and y times their acceleration. Plug in numbers, and we get A equals to 2 meters per second squared. Then for block y, same thing here, put down F equals to ma first. In this case, the resultant force on block y is 12 Newton minus tension, which equals to the mass of y times its acceleration. And plugging numbers, we get tension equals to 4 newtons. Let's summarize the general approach to this type of problem. If you apply the Newton's second law to the whole system, do not include the tension in the string. Only consider external forces like the pulling force, pushing force, and the friction. On the other hand, if you apply Newton's second law to one object only, you must include the tension of the connecting string, along with other forces on that object. Before you go, may I know your preferences? Do you prefer my real voice or the AI voice? Please let me know in the comments.